Oftentimes when you ask an IT manager what kind of availability is necessary, they're going to spout off some arbitrary statistics like, well, we require three nines, 99.9%, or five nines, 99.999%. And they think that in that response, they basically answered all of the questions that go along with availability. However, in reality, just allowing a few nines to roll off their tongue is not going to answer the questions that need to be answered for effective availability management. And we're going to look at availability management in this CBT nugget of the itil series. Now, what are some of the initial questions? Well, we should ask, how do we define availability in practical, measurable terms? And for that matter, how do we define unavailability? For example, if you have 1,000 users of a service, let's say the network infrastructure, and one of the users can't access the service, do you consider that service to be available? Also, what type of availability metrics and parameters should be captured and reported? And which of these availability metrics should be reported to the customer or the end user? So we're going to answer these questions and much more in this nugget. In itil availability management, we're going to cover 5 key topics. First of all, we'll explore availability management in a nutshell. Then, we'll look at the 3 key guiding principles of availability. You need to know these. We'll also look at some basic availability concepts and terminology. And then we'll look at the availability process and activities, and then finish up with a brief overview of some common availability methodologies. For most IT professionals, the concept of availability really gets down to, in the past, is your mail server available? Is your database server up and running and servicing database queries? Is your router or switch up and running and processing throughput? But for itil services, availability is a lot more than that. As a matter of fact, it's basically guaranteeing that all of the IT services, all of the ones that are covered in a service level agreement, are there when necessary. And these are, of course, are defined in the service level agreements through integration with service level management, that aspect of itil service that we looked at earlier in this nugget series. Availability is going to manage and monitor services from end to end, from customer to provider, from end user to provider. It's also tightly coupled with the problem management structure. And that makes a lot of sense because often it's problems that arise in our network infrastructure or in our environment that lead to unavailability or the non-availability of hardware and software, applications and services. So by dealing with the problems quickly and resolving the root cause of the problem, we can make sure that next time our 99.0 availability can maybe get to 99.9 availability by eliminating potential problems and incidences. The goal of availability management, in a nutshell, is to optimize the IT infrastructure so that the level of availability guaranteed in a service level agreement is met on a consistent basis. That's a great definition to remember. And this all goes back to maintaining on an ongoing basis customer satisfaction, end user satisfaction, and constantly improving the IT environment. The concept of availability and availability management are both found in the service design book of the ITI library. Availability is the ability of a configuration item or an IT service to perform its agreed function when necessary. This is determined by things like reliability, maintainability, serviceability, performance, and security. And we'll talk about these things in this Nugget movie. As I've already mentioned, in the end result, availability is typically calculated as a percentage. 99.0, 99.1, 99.9, 99.99. And we derive this percentage based on the agreed service time documented in the service level agreements and any downtime. So availability management is simply a process that we use to define, to analyze, to plan, to measure and, of course, bottom line, improve all of the aspects of the availability of all of our IT services. And that means when we define service level targets for availability with our customers or our users, we're going to make sure that all the IT infrastructure, all the processes, all the tools, all the roles are appropriate and are in place. Next, let's look at the three guiding principles of availability. First of all, our IT services must be consistently accessible. Availability management is essential for getting a high degree of customer satisfaction. And we get that satisfaction by making sure that the services that we're offering are almost always available. Availability and reliability are the things that we use to help promote to the customer the level to which our services are delivered. The second key principle is that there's going to be disruptions, okay? There's going to be, that's why this is tightly coupled with problem management, okay? One-time disruptions will happen, but they must be addressed rapidly and completely. And the goal here, the principle, is to get to the point where you have no repeat incidents. No repeat incidents based on problems not being solved or rectified. Now, there's always going to be faults, even if you have a high degree of availability. So availability management is also a professional response to all undesirable situations. And then third, availability is what we would call a mission critical business service. It's a critical aspect, a critical component of our IT infrastructure. This has to go into the design process. When you're designing your IT solution, availability has to be part of the equation when you're going out and acquiring hardware and acquiring software and building your solutions. For example, if you're going to put together a high-speed switched network for a customer, are you going to have redundant systems, redundant high-end switches, and redundant power supplies in those network devices? Are you going to purchase along with the devices uninterruptible power supplies, or maybe possibly generators? If an application that's running off of a server fails, how can you have a failover system to keep that application available? For example, if you're using Microsoft Exchange, for instance, and an Exchange server goes down, what type of failover process do you have, or clustering solution, to keep that Exchange mail and collaboration solution available? So these are mission critical business aspects. These are the three key principles. Consistently accessible, understanding you have one-time disruptions but no repeat incidents, and understanding that availability is mission critical from a business standpoint. As you can see, availability is all about ability and capability, and there are four basic abilities of availability. Obviously, you've got availability itself, you've got reliability, you've got maintainability, and you've got serviceability. Now, earlier I mentioned also a fifth aspect, and that is security. But we're going to cover the security aspect when we look at security management in an upcoming Nugget movie. High availability is the aspect of continuously providing the IT service to the customer with very little measurable downtime and a rapid service recovery process. And again, to achieve this, we're going to measure this by metrics. So all this is going to depend upon how complex our IT infrastructure is, how reliable the components are, how quickly and effectively individual users and systems can respond to problems, faults, or incidents, the quality of the support, and that gets down to the IT professional. Also, the quality and scope of the operational management process, and that's where the itil really comes in. Reliability basically means that your service is available for an agreed upon period without interruption. Reliability also includes a concept known as resilience. Resilience is the ability of an IT service or a configuration item to resist failure or to be able to recover quickly after a failure. For instance, the network interface on a router can allocate higher bandwidth when necessary to respond to a denial of service attack. This is known as resilience. Also, resilience is the ability of a service or a particular component to operate efficiently and effectively even if one or more subsystems fails. A simple example would be, let's say, an end user's workstation. If that end user is to, let's say, download some type of spyware or adware that interrupts their web browsing service by putting up a bunch of pop-up windows or adware pop-ups, is that going to affect the other subsystems of the workstation? Is it going to use up so much memory and processor that other tasks that might be running simultaneously to the web browsing are going to be adversely affected or killed completely? That's a simple example. But on a server level, if I've got an Exchange server, for example, on Windows 2003 or Vista, and that Exchange server is also providing other services, if one of those other services failed, is it going to affect my mail and collaboration service with Exchange? This is one reason why most organizations are going to dedicate their mission critical services like mail and collaboration and database and certain applications to dedicated clusters of servers, oftentimes on their own switch networks, which themselves have redundant routing paths and redundant high-end ether channels. So reliability is a measurement of how long an IT service will perform its agreed function without being interrupted. And again, this is usually in measurable terms, and we'll talk about some of those metrics and parameters here in a moment. Next, if you want to know how quickly and effectively an IT service or a configuration item can be restored to normal working operations after it's failed, then you're talking about maintainability. Maintainability deals with service restoration and disaster recovery. It includes preventive maintenance and scheduled monitoring and scheduled inspections. This would be taking actions to prevent future faults. Remember, it goes back to that concept we talked about earlier of firefighting. Firefighters are going to spend most of their time going around the public and talking about fire prevention rather than just fighting fires all the time. Maintainability also relates to detecting faults and making a diagnosis of those faults, and again, tightly coupled with problem management. It may also mean putting into place components, let's say a Cisco ASA device that has automatic diagnosis on its own and can generate reports and logs that point to the source of the problem. Maintainability deals with resolving the fault, recovery after a fault, and restoring the service. And the fourth ability of availability management is that of serviceability. And this is that basic contractual obligation that service providers have to customers and users. These are the contracts, the service level agreements, the service level targets. Next, we need to identify the three different levels of availability. And this is according to the ITIL. One way to help you remember these is to simply attach to these a keyword. For example, high availability relates to unplanned. Continuous operation relates to planned, and continuous availability is planned and unplanned. Let's define these. High availability is the process where you are going to shield or completely isolate customers from a component failure. And you can do this, and this is again an unplanned failure. And we do this by providing what are known as clustered failover configurations. For example, a cluster of Windows 2003 servers where I would have, and these boxes represent servers. Well, we can say these are on separate boxes, or these could be rack mount blades, for example. But you've got, let's say, these IBM servers running Windows 2003. They're on a fast switched network. Maybe they're in a rack. And what you're doing is you've got three physical devices that are using clustered services, clustered technology, and they're being represented by and I'm going to use dots here because these dots represent virtualization. They're being represented by a virtual server. So these might have all three separate IP addresses, .10, .11, and .12 on, let's say, a 10.128.1 network. Okay, and these are physical devices, physical servers with IP addresses connected to maybe one or redundant high-speed switches, but they're being represented okay, to end users and customers by a virtual server that's on another IP address, let's say like .15. So you're virtualizing three servers in the background here by presenting one virtual server to the public. So these clustered failover configurations work so that if one physical server goes down, the other two can take up the load. Or if you've only got two, if one goes down, the other one can take up the load. And you've got different types of configurations where the failover server will only come up when one server fails, or you could have both of these active together at the same time. Redundant appliances, redundant physical network circuits, and redundant routing and switching logic. And so we can depend upon redundant switching channels. Let's say multiple ether channels. We can rely on routing protocols like open shortest path first and BGP to give us some redundant routing logic. That's high availability. Continuous operation, on the other hand, is a planned activity. This attempts to protect users and customers from the adverse effects of planned downtimes or planned outages. For example, one of the projects I've done with State Farm is to go around and replace and upgrade all of their servers and their UPS or uninterruptible power supplies that are servicing the servers and the router cabinets with the router and the switch and the modems and those things. Well, to replace the power supply, I have to bring down that office for about 20 to 25 minutes while I replace the power supply, and I also configure the management tools that go along with that power supply and the operating system. So I have to protect users and protect the business from any adverse effects of the process of replacing that UPS. You can also use load balancing capabilities and clustering techniques to allow individual services or individual components to be brought offline without disrupting the service altogether. So for example, if you have a load balancing solution with a SQL server or with an Exchange server, while you're replacing one server, let's say the primary server, you can make that backup or the failover secondary server, you can bring that up as the primary unit while you service or bring offline the previous primary unit. So if we go to this diagram down here, let's say I've got two servers working together in a failover solution. I've got Exchange Server 1 and Exchange Server 2. This is my primary server, which is always on. This is my failover server that only comes up when I've got a failure or an outage. If I have to do an upgrade or an update, and I have to do, let's say, several restarts of this server while I make changes, I can basically bring this one offline and bring this one up as my primary server, and this can serve my customers and users while I'm doing the voodoo that I do to this previously primary server. Continuous availability is a concept that deals with planned and unplanned downtime or outage, attempting to isolate users from the effects of unplanned or planned downtime. This is a combination. I got a little spelling error here, but I don't want to redo the graphic. COM. This is a combo of high availability and continuous operation. Again, using cluster technologies, load balancing technologies, failover configurations with redundant software and redundant hardware scenarios. Now remember, out in the industry, whether you're dealing with database solutions or mail solutions or other application solutions or even physical implementations, these concepts of availability and terminology may be different. But as far as the ITIL is concerned, these are the three you want to be aware of. Let me show you a real-world example of this kind of reliability and availability concept. This is a firewall solution. Notice I've got a logical object here representing a firewall. This is a Cisco PIX 535 device. And what we have is we have one primary firewall and then Connecting these two devices is a failover cable. If we look at the back side of this firewall appliance here, you can see this DB15 connector. So you're going to have a serial cable that connects here that goes to another redundant device, your secondary device. Of course, this is probably right there racked in the same rack cabinet in the server room or wiring closet of your small to medium sized business. And this failover cable is what provides this failover solution. So as your devices access this network, this 1.0 network, to get outside to the internet, this firewall is servicing traffic coming in and out of the network. But these devices have software along with the failover cable that allows, if this device fails, within a matter of seconds and transparent to the users inside and out, it can bring up this other secondary device. Now notice another level of redundancy here. We've got redundant slots, for example, redundant interfaces, but we've also got redundant power supplies. And some of the high-end devices will have redundant power supplies so that if one of these power supplies fails, and if you've been computing for any period of time, whether it be a workstation or a server, you know that eventually those power supplies are going to go out, either just based on the device just simply running the course of its manufactured capabilities, or due to some type of power surge or lightning strike, it can knock out that power supply. So this device also has availability and reliability built in with the power supply itself. And of course, you can go beyond the device, having devices, each one of these on its own circuit breaker, and maybe even having multiple power companies, multiple providers of power, as well as a generator. Here's another example of not a firewall solution, but VPN concentrators that are actually servicing virtual private networks for an IP security solution between a small office, home office, and the headquarters using the public internet. You can see I've got a master Cisco VPN concentrator that can terminate a bunch of site-to-site VPNs as well as remote access VPNs from users that are logging in, let's say, from a wireless hotspot from a hotel room using their laptop and a VPN client. And you can see here I've got this kind of cluster of a master with two secondary VPN concentrators, and you can see they have their own IP addresses, .5.6.7, but we have a cluster being virtualized and represented by one single virtual IP address of 1.150. So all of these small office, home office sites, all of the branch sites, all of the remote users that are accessing are basically going to configure their software to connect to address 1.150. But behind the scenes here, you've got this cluster of three devices, a master device and two secondary devices. And it's a combination of hardware and software that provides this cluster failover solution. And if there's beads of sweat rolling down your forehead right now, and this goes way beyond the scope of your IT knowledge, don't worry. As far as the ITIL is concerned, you don't have to understand these different implementations and configurations and designs. This is just to give you a picture of what we're doing when we provide reliability, availability, and maintainability. And you can see here it's done at the physical and the logical levels. And just like capacity management that we saw earlier in this ITIL series, we had a process or a set of activities where you have inputs into the management process and then, of course, outputs based on the different sub-processes. We have a similar thing here with the availability process. We're going to put into place for our customers, based on service level agreements, duplicated essential components, fault detection, and fault correction systems to meet our standards of high availability. Whether it's high availability, continuous operation, or a combination of both, continuous availability. So what are the inputs into the process? Well, we're going to evaluate the requirements for availability that the business needs, whether this is our business working internally or whether we're doing this as a provider, a service provider for a customer. To use the examples earlier, do we need availability for providing network services like an ISP? Do we have to provide reliability and availability for firewall devices or VPN devices, edge routing devices, those types of things? We also want to do an impact assessment. What is the impact on the organization if these availability solutions are not in place? The requirements for availability, the requirements for reliability and maintainability, and the costs of providing these services. We also have to merge this with any incident and problem data on an ongoing basis. Remember, it's those incidents, it's those problems that can be indications of lack of availability, lack of reliability. It's the configuration items in the problem database that are going to lead us to creating redundant systems, to put in clustering solutions, and to create redundant hardware and software solutions. Other inputs into availability management would be the service levels, the service level targets, the contracts, the service level agreements themselves. Then, of course, in the availability management process itself, we'll be looking at the availability plan, ongoing monitoring, measuring and reporting, designing for availability and maintainability, maintenance management, measuring, reporting, taking into consideration the key security issues. Then the output from availability management will be a wide variety of things. The output will be results of recovery design solutions. It'll result in IT infrastructure resilience assessment and risk assessment. So all this information can go into our risk assessment and disaster recovery plans, written processes. Any written agreed targets or contracts for availability, reliability, and maintainability. It'll generate reports. It'll generate summaries for middle and upper management and other stakeholders. It'll output availability monitoring via, let's say, Cisco Works software or Cisco Mars or some other HP or Computer Associates solution. And of course, the bottom line, the availability management process is going to output plans for constant and continual improvement. So here's a flow chart of the process of availability. First of all, for our customer, we're going to determine the availability requirements. Do we need availability for the network infrastructure? Do we need availability for web server farms and web servers, exchange or mail-in collaboration servers, database servers, other application servers? Availability for network appliances like firewalls, VPN concentrators, routers, and switches. Availability in high-end workstations. So we're going to do an analysis of the organization to determine our availability requirements. Then, based on the information, we're going to design for availability. This means isolating any single points of failure, identifying any vulnerabilities, putting together a good design. This could entail what we call a CIFA. A CIFA is a component failure impact analysis. A CIFA is a technique to help us identify the impact of the failure of an IT service or a configuration item. Basically what you do is you create a matrix of IT services to help you identify critical configuration items and critical services, as well as fragile IT services. A fragile IT service would be one that's, say, like a single firewall appliance that has a single point of failure, perhaps a single switch that connects a building to the distribution part of your network. Next, we're going to design for maintainability. And since we can rarely get 99.9999 uninterrupted availability, you know you're going to have periods of unavailability. So we have to consider this and what are we going to do during those maintenance processes? What are we going to do during those times where we have to replace the UPS or update or upgrade different services? Escalating, merging, migrating, backup and recovery, those types of things. So design for maintainability. Then we're going to identify any security issues that go along with this process. And again, as I mentioned, we'll look at security management in an upcoming Nugget movie. Then we'll look at the process of maintenance management. Scheduling windows of unavailability for periodic maintenance, upgrades, updates. And this could be based on that CIFA that we just mentioned. Of course, the next thing after maintenance management is an ongoing process of measurement and reporting. And there's different types of measurements. And so what we want to do is we want to kind of define some of those things here real quick. And there's a great saying out there that says, if you don't measure it, you can't manage it. If you don't measure it, you can't improve it. If you don't measure it, you probably don't care. And if you can't influence it, you know what? Then don't try to measure it. So let's talk real quick about some of these measuring techniques. And we're going to focus on three metrics. Again, there's a lot of different things here, very complex, but for the sake of the ITIL foundations, we want to focus on three metrics. MTTR, mean time to repair, MTBF, mean time between failures, and MTBSI, mean time between system incidents. Oh, and by the way, just to finish up the slide here, this is all going to lead to our written availability plan, or AP. As I mentioned, MTTR stands for mean time to repair, and this is basically in a nutshell the average time that it takes to repair after a failure. For example, a router or a switch fails, how much time, hopefully in minutes, possibly hours, even days, is the average time to repair once this particular component fails. It could also be the same thing as the IT service desk. If the IT service desk is down, or the change management database or the problem management database is down, what's the average time to repair those services once they fail? Keep in mind, the MTTR does not include the time it takes to recover or restore the service or the configuration item. MTTR is closely related to this MTRS down here, the average time it takes to restore after a failure. That's called mean time to restore service. It's sometimes incorrectly used to mean the same thing, but it doesn't. As a matter of fact, the MTRS is the average time taken to restore a configuration item or a service after failure. It goes beyond just repairing. It talks about fully restoring and delivering the service or the component to its normal functionality. So if you want to compare the MTTR and the MTRS, one way to do it is this is just simply repairing after a failure, and MTRS is restoring it back to its full and normal functionality. The MTBF is the mean time between failures. This is a metric for measuring and reporting reliability or resilience. It's the average time that an IT service or a configuration item can perform its agreed function without being interrupted. This is going to be measured from when the CI or the service starts to work until the next time it fails. The next metric is MTBSI, mean time between service incidents. Basically, MTBSI is the mean time between failure, MTBF, plus the MTTR, the sum of those two metrics. MTBSI is used for measuring and reporting reliability as well. It's the mean time from when a system or service fails until it next fails. These are four key metrics to be aware of that are used for measuring availability, reliability, and resilience. Finally, there's four main methodologies to be aware of for availability management. These are overall methodologies. Each one of these could generate and has its own textbook. So we don't want to worry too much about every detail, but we'll give you kind of a brief overview here of these four different methodologies. The first one we've already alluded to earlier on. That's component failure impact analysis. As I mentioned, this uses an availability matrix. It includes strategic components as well as their roles in each ITIL service. You're going to use the configuration management database to help develop this matrix. Another methodology is the fault tree analysis, FTA. Fault tree analysis goes beyond just being used in information technology. It's also used in safety engineering, where an undesired effect or root problem is the top event or the root of a tree of logic. Then each potential situation that could cause that effect is added to the tree. So it kind of branches out into a tree of logical expressions. And this is used as a common methodology for probabilistic risk assessment and availability assessment and analysis. CCTA risk analysis and management method, or CRAM, was created in 1987 by an agency of the UK government. Right now it's on CRAM version 5, and it has 3 stages of activity. First of all, in stage 1, you have the establishment of the objectives. This defines the boundary for the analysis, identifying and valuing physical assets and part of the system. Step 2, or phase 2, is the assessment of the risks. The risk to the proposed system, the risk to the service, and requirements for security. And then stage 3 of CRAM is to identify and select countermeasures. As you can see, this is a very broad methodology that can be used in a wide variety of disciplines, including availability management. And the final methodology is SOA, Service Outage Analysis. SOA is a technique that can be used to identify the causes of faults. It investigates effectiveness of an IT organization and its processes, and it presents and implements proposals for improvement. SOA, like CRAMM, has a real broad scope. It's not limited just to infrastructure, but it covers processes, procedures, even cultural aspects of your organization. You always approach it from the customer's perspective, and some organizations will actually put together what's called an SOA team, a Service Outage Analysis team. For more information on these methodologies, feel free to go do a Google search and do a little bit of research and some homework. In this ITIL Nugget movie, Availability Management, we covered 5 key topics. First of all, we explored availability management in a nutshell. We looked at 3 key principles of availability. We explored some basic availability concepts, looked at the processes and activities, and finally, 4 key methodologies. I hope this CBT Nugget's been informative for you. I want to thank you for viewing. See you next time.